All right, we're recording now.
All right, thanks, Ellen. So welcome to weeks 11 and 12. Looks like most of you have gotten some kind of a head start with sentiment analysis. So these 2 weeks we are going to be focused on doing sentiment analysis, but the 2 weeks are also just as much about getting to know the DB2 warehouse on IBM Cloud and being able to use analytic tools directly on the DB2 database. So there are going to be lots of moving parts, of course, in the tutorial and also in the assignment that is coming up next week. So first you should be able to create your own version or instance of DB2 on the cloud warehouse, and then load data into tables, explore the tables, connect RStudio to your table or to your schema, and then use the statistical functions in R to analyze those data. And the analysis you are going to do is going to focus on extracting the statistics related to different sentiments expressed in the Twitter data that you are loading into the DB2 tables. Okay. So I know that it's going to be, I think Helena said, some students in the past felt that this is the toughest assignment in the whole course. So what we will do is I will quickly walk through the theory behind sentiment analysis, look at some algorithms for sentiment analysis, and then Elena will walk us through the tutorial. Okay, so I hope to reserve more time for the tutorial walkthrough. Okay. All right. So here is a definition of sentiment analysis that I like. It says that sentiment analysis or opinion mining is the computational study of 3 things, specifically opinions, attitudes, and emotions expressed in a text or document. Okay, so opinions can include judgments and subjective evaluations, etc. Okay, attitude is almost the settled way of thinking, the viewpoint of the person. Okay, people come with different attitudes to the table. What they perceive are influenced by their attitude. Okay, so that is specifically different from opinions. And finally, you have emotions. These are the emotional states under which the person was when he or she typed up a text message or a Twitter message, and things like that. So if you look at what kind of information is going to be useful to a business or to any consumer, those sentiments generally fall into these 3 categories. People express opinions about products. They express opinions about, policies, political candidates, etc. And those opinions are also heavily influenced by their own attitudes. And when somebody is evaluating a particular product or, rating a movie, the emotional state of the person also influences the rating or the scores that they give to the products and the movies. Okay, so all these three are distinct sentiments, distinct classes of sentiments that we are generally interested in, and the main goal is to determine the polarity of each sentiment. So what we mean by that is does this text express a positive or a negative opinion is what we want to know. Okay. Sometimes the intensity of the polarity is also useful, but that involves a lot more computation and a lot more analysis. Okay. So generally what we are interested in are the polarity of the sentiments. So that includes the emotions, attitudes, opinions. So you could have positive or negative emotions. So those could be, just broadly speaking, positive emotions are happy, negative emotions are, anger, sadness, and things like that. Okay, and also in most analysis and in most data science work related to sentiment analysis, we try to avoid the neutral category so that we can get more, more precise results, more selective results. So the polarity usually, if the sample data has a lot of neutral emotions or neutral attitudes, it's good to initially screen them out if you can. Okay, so that improves your classification accuracy, and we will see why later on, because sentiment analysis is probably one of the most difficult classification or estimation tasks that we will ever encounter, and therefore, we try to simplify the problem itself as much as possible. Okay. So, what are the different types of sentiments that a data scientist should be interested in? And I just listed three, opinions, attitudes, and emotions. But there are other viewpoints out there. I guess I can say there are other opinions out there. So, for example, in this book, Speech and Language Processing, the authors rely on a psychological model of emotion proposed by Scherer, and it's also, it's also tightly related to the sentiment analysis that you will see on the Stanford NLP website. They look at 5 broad categories of sentiments. Okay, so you can see them listed here: emotions, mood, interpersonal stance, attitude, and personality traits. Okay, you can see that there is some overlap between the list I have on the left side and this list, but some are, I feel that some of the categories in the broader list on the right side are not very conducive to statistical analysis. So, for example, mood could be related to emotions, but they are trying to distinguish between a person being sad and a person being depressed. And I don't think the tools we have now are sophisticated enough to make those distinctions. Okay, so I mean, you will see a lot of you will see this list also being talked about and used a lot in sentiment analysis. But so I want you to be aware of the problems with directly taking a list of psychological traits and applying them to sentiment analysis. So, so again, there is a category here called personality trait, and they list nervousness, anxiety, and things like that. I have no idea how you can use statistical models or NLP to arrive at those, to identify those personality traits. Okay, I just think it's not feasible. Okay, so we will stick to the list of 3 sentiments listed on the left side. Okay, so that's the types of sentiments that we will be dealing with, and what are the challenges in sentiment identification. There are many, many challenges, and most of them are related to how we use language. Okay, human beings are very, very creative with language, and that is a problem for NLP in general, but more specifically, it's a bigger problem for sentiment analysis. Okay, so the language structures that pose major challenges to sentiment identification are listed here. Okay, I listed some on the top, like metaphors, idioms, sarcasm, irony, and things like that. I don't think similes are much of a problem, but it's simply because I haven't been able to find an example where you can express a contradictory emotion with a particular word. Okay, so let's go over some examples. You can start with a simple question like, "How was your day?" And you can get a reply, a response, great, and that is clearly a positive sentiment. Good is also a positive sentiment, but not as positive as great. So you can see a level of intensity there. You could say okay, which is neutral, bad, terrible. Those are more negative sentiments. And then we encounter a whole bunch of situations that are going to be very difficult to deal with in statistical models. For example, if you have lots of examples in your data that have the word bad, and those examples are associated or labeled as negative sentiment, then your classifier or your model is going to learn that strong association. And then when it encounters a text like not bad, which is going to happen much more infrequently than the word bad itself, then it's going to be confused. So in this situation, it is probably going to classify not bad as a negative sentiment, okay, unless you take negations specifically into account in your pipeline. Okay, at some point you have to say, okay, these are the words or the entities I am trying to extract, but I also want to associate negations with the corresponding sentiments, and then you use that whole bag of words or whole list to train your model. Okay, so in that case, not bad will become synonymous with good, and we will look at some examples of how that can be done in classifiers. Okay, so do you understand the issues now? Somebody could say something like peachy. That is, obviously a very creative way of saying good, and there are going to be and those types of occurrent words or phrases are going to be very infrequent. Not everybody says peachy when you ask them, "How was your day?" Right? And then you get into things like sarcastic comments. Somebody could say, "Oh, it was so awesome," or something like that, and they mean the exact opposite of it, right? And that brings us to the other two examples. You could use the same adjective and sometimes even the same adverb to to flip the meaning of a sentence. So, for example, you can say the pain in my back was excruciating, and that is a strong negative, sentiment. On the other hand, you could say the process is painful but not excruciating, and that should be treated as a somewhat positive sentiment, okay? And then you get into all these idioms and, colloquial terms like not the sharpest tool in the shed. How do you get your classifier to recognize that that is a negative sentiment expressed towards a person? Okay, so if you go back here, you got interpersonal stance or attitudes or even an opinion of a person. So this we when you have an opinion classifier and somebody says not the sharpest tool in the shed, which is probably not going to occur too frequently compared to phrases like he's just dumb or something like that. So the classifier is not going to pick up the true sentiment behind this sentence, okay, which expresses a negative sentiment towards a person. Okay, so I have more examples here, empty suit and things like that. And then you got oxymorons like good grief. Now, if your clustering algorithm has only encountered good and grief separately, the first time it encounters good grief, it's going to be confused. So, same thing with soft rock and things like that. Okay, so these are the challenges to sentiment analysis. Of course, there are challenges to NLP in general, but more so for sentiment analysis. And I have an example at the bottom. Okay, it says, colorless green ideas leap furiously. This is a sentence that was coined by Chomsky. It is a perfectly grammatical sentence with absolutely no meaning. It's a meaningless sentence. So you could have, there is this difference between being grammatically correct and making semantic sense, okay? And psychologists and linguists generally think that these are two different systems, that you have a system in the brain that deals with universal grammar, okay, so you are able to generate grammatically correct sentences, but they don't need to have meaning, okay? Now, when we use statistical analysis to identify sentiments or to classify texts according to their sentiment polarity, we are almost thoroughly ignoring grammatical correctness, okay? The statistical models are going to look only at specific words that are or phrases that are informative for the classification task, okay? So, even the phrases we use like bag of words, okay, or word to wick, they already tell you that we are ignoring the sentence structure. We are treating a sentence as if it is a bag of words, okay, with no particular order or, recurring structures and things like that. So, you have to be aware of the fact that in most of what we do in sentiment analysis, any classifier you build or any identification model you build is it almost always ignores grammatical structure, and it focuses solely on extracting the meaning, the semantics, based on the statistical nature of the sentence. Okay. So there are lots of different approaches to sentiment identification. I have listed two here. the simplest approach is shown on the left side, and then the probably the most complex approach around is shown on the right side, and you could have anything in between. Okay, so it just depends on how sophisticated you want your system to be. You can have as many models and processes in your pipeline as you want. The simplest model here shows you how you could take product reviews and identify sentiment polarity. Okay, is it a positive review or a negative review? So if you can, if you think about all the Amazon reviews of different products, people give a numerical rating from 1 to 5 stars, and they also have a summary text. So now you can pick all the texts that are associated with 5 stars, call that positive review, all the texts associated with 1 star, and call that negative review, and then just build a classifier. And the process is exactly what you would expect from, what you studied in the first 3 or 4 weeks. It's going to be a simple NLP model where you first identify the sentiment, and that is, the data. If you are using Amazon reviews, the labels come with the data set. Okay, so you don't have to annotate the text and say, okay, this is negative sentiment, this is positive, this is neutral, etc. Okay, you can just use the ratings as a label for the text. And of course, you got to do your feature selection. You could do, tokenizing. You could do, sentence boundary. You could do tokenizing, part of speech tagging, and lemmatization, stemming, and things like that. I'm sure you are already aware of some of these things. And then at the end, you have the sentiment polarity classifier. Okay, so that's the simple process. So let me just, in case you have forgotten, let me quickly go over these different boxes you see on the right side. Sentence boundary disambiguation is just exactly what it says. It extracts different sentences. So if you put a long paragraph in your data frame and you do a flat map, the result should be individual sentences, individual sentences that are separated by commas. Part of speech, of course, you want to tag every word in each sentence as either a noun or a verb or an adjective or an adverb, and pronouns, etc. And those can be in some situations, those can be very useful information for the classifier. Okay, so if you're trying to identify a particular entity that is a noun, then having an adjective in front of it, increases the likelihood that this particular word is a noun. Okay, and having an adverb reduces the probability of the current word being a noun. So those are going to add more information to the model. Okay, and lemmatization and stemming, again, you want to have a basic ground representation for each word. For example, eat, ate, eaten, eating should all be reduced to one basic form, let's say eat. Okay, so that's what lemmatization and stemming do. And once you have done all that, you extract statistical parameters, metrics from the whole document class. Okay, so that's what your tutorial is all about. You're gonna load up all the tweets, and you're gonna clean them up initially, remove punctuations, remove all kinds of weird symbols that we use, characters we use like a hash, and then you tokenize what is remaining, and then you remove all these top words, which are, a, the, and, so because they don't add any meaning. Okay. Now, this is what I meant when I said our approach is going to be the extraction of meaning from using statistics. We do not care about the grammar or grammatical correctness of a sentence. Okay. Okay. So that's the general approach to sentiment identification. Now, you may be wondering how, this statistical approach works at all. Okay. As I said, we are completely ignoring grammar, but no two human beings will ever make sense to each other if they only, speak words that have, and they have completely stripped out all the punctuations and all the stop words from each sentence that they are saying. Okay, it will not make normal sense to normal human beings, right? And yet, it is that residual bag of words that are used to build classifiers for sentiment analysis. We are claiming that we can extract the emotion behind a statement by simply looking at this residual set of words without the punctuation, without capitalization, without, without all the stop words, and by reducing every word to its stem. Okay, now why is that? Why is that even possible? How is that even possible? And nobody really knows, but one thing we know for sure is that almost all human languages obey something called the Zipf's law. And so let's say you take a long Shakespeare drama or something like that, and you look at the most frequently occurring word, okay, and it occurs with some frequency, let us say F. Now you look at the second most frequently occurring word, okay, it will almost always occur at a frequency of F over 2. Okay, if you look at the third most frequently occurring word, its frequency will be F over 3. Okay, so the nth most frequently occurring word in any language will occur at 1 over n times the frequency of the most frequently occurring word in that language. Okay, now this is a statistical law. The fact that we call it a law says that we don't understand why it is true. Okay, but there are some statistical regularities to most human languages. I have listed some here. Of course, English is one of them, and and you can see that they all obey Zipf's law here. The axes are log, so it's a log plot. So it looks like a straight curve, but it is actually 1 over n. So it will be a 1 over n curve. All right, so there is something going on here that we don't understand, but we are exploiting this fact. Okay, so here is one method, the first method of doing semantic analysis. It's called latent semantic analysis. You will be encountering parts of this in your tutorial. Okay, so I have shown the term document frequency matrix, which will be generated when you plot certain things in the tutorial. So every column is a tweet or a document, and every row is a term. Okay, so for example, the term flight occurs in the first document once. It does not occur in the second, third, fourth documents. Okay, the term unit occurs in the first document, second, and the third. And in fact, it occurs in almost all the 22 documents we see here. Okay, so now this matrix that plots documents as columns and terms as rows is a, it's almost a standard structure that is going to occur in a lot of NLP analysis. Okay, now the quantity that is actually filled in can change. It can be a simple frequency, it could be a count, or it could be something more sophisticated. And I will show you some more sophisticated metrics later on, okay? But this is the basis of designing any sentiment classifier, okay, or polarity classifier. So you take this matrix, you fill it in with frequencies or some version of frequencies, and what latent semantic analysis does is do a dimension reduction along the, I should say, the y-axis or the rows. So it simply takes this and reduces the number of rows without losing much information. Okay. In other words, what it does is it finds synonyms, similar words, or words that occur together very frequently, words that are highly correlated. And then it comes, for example, car, truck, flower. Okay, those are three distinct words. There are three distinct rows, and they can all be combined into a single row using this equation because there is a high level of correlation. You will realize that this is just a dimension reduction technique. Okay. And there are a number of dimension reduction techniques like principal component analysis, singular value decomposition. So you can use any of those dimension reduction methods to take this matrix and reduce the number of rows. Okay, so that you have fewer computations to do. Okay, and the idea behind dimension reduction is very simple. You take, let's assume D is the main matrix, the complete document frequency matrix you have. And you are trying to find an estimate for D, which is D hat. And this norm, which is a Frobenius norm, is simply the root mean squared, okay, or root sum squared of the difference terms. So all you are trying to do is find a matrix that is very similar to the original matrix, but has fewer rows, okay? And you're trying to minimize this Frobenius norm, which is the root sum squared of the differences. And when you do that, one way to do it is to use singular value decomposition. You have D equals U sigma V transpose. And, sigma is a diagonal matrix. And then you can factor U and V into submatrices like this. And you can pick just one part of U and one part of V and one part of sigma, and you have your reduced dimension matrix. So this is what you work with, okay? As you can, I think some of you already encountered this problem today. When you are trying to view the document term frequency matrix, it took a long time because, that's a lot of data. Okay, what this technique does is without losing information, it shrinks that matrix. Okay, and that's all there is to latent semantic analysis. Okay, so instead of just filling in the term frequency, you can also fill in the TF IDF, that's term frequency and inverse document frequency. Okay, so think about this. Let's say you have a term that is that occurs with almost the same frequency in all the documents. Does it provide any information at all for the classifier you're trying to build? No. Okay. So let's say this is a high frequency word. If you only use the term frequency, that is going to influence your classifier because it's a high value, right? Now, but it is occurring in almost all the documents. So it cannot be really adding much value to your classification problem. So what we do in TF-IDF is you take the inverse of the document frequency, okay, which is how many documents have this word. Okay, if a lot of documents have this word, then you are going to weight that frequency down, weight the term frequency down, okay? So for example, let's say here you see the word unit, okay? It occurs with a frequency of 1 on almost all the documents. It's not going to add any value to the classifier, to the classification problem. So now, if all the 100,000 documents have this word unit, then you will not be entering 1 in those cells. You will be entering 1 over 100,000. So you're weighting down that value, okay? On the other hand, if a word, okay, if a term frequency is very small, in other words, is the frequency of occurrence of a particular term is small across the whole corpus, okay? But at the same time, it also occurs in very few documents, okay? So you have to weight that frequency up a little bit because, it is not indiscriminately occurring in all the documents. It is very specific to certain documents. So that is what is happening here. And, because of all this statistical laws I explained, slightly, earlier, we have a log function. So TF I, j is the term frequency of the ith term in the jth document, and DFI is the document frequency of the ith term. In other words, how many documents actually have that term, okay? And this matrix should be populated then with Wij, and you have a more sophisticated representation for the matrix. And now you just use this to do anything you want, And, you've seen a lot of pipelines before. All you have to do, after you have gone through all these steps, is just build your own pipeline to do polarity identification. Okay. Are there any questions? Please type your questions to everybody. Let's just take a few minutes to answer any questions about sentiment analysis, and then we will move on to Elena's walkthrough. Any questions? Okay. Looks like nobody has questions, and this recording is, of course, going to be on your course website. And, I look forward to hearing new ideas and opinions and emotions on the discussion board, okay? So, Elena, are you ready?
Yes, I'm ready, yes, okay. So, I'm going to take the presentation, right? And let me see, okay. So, I have to share my screen, so let's do that. Okay, so share my screen. All right. So here it is. This is the second set of slides, and this is for the sentiment analysis and the assignment 4. Okay, so what I did was here, this was just as a reminder, I added this quote for you guys. So it says that procrastination is a theft of time. So if you're working on this, when you're working on this assignment, keep it in mind, because In the past, some students told me that this assignment may have been the hardest in the program. Well, that's a feedback that I received, alright? Alright, so here are the things that we are not going to do, right? The walkthrough that you just worked on, some of you just started working on, it tells you what you need to do. But we also need to go over what not to do. So you're not going to wait until the last minute. You're not going to add more than one copy of the service at the same time, because what happens is that if I add 2 copies of this service, then I'm going to be in trouble, because essentially I'm having 2 separate database accounts. And it's going to be like this. I created my table. Huh? Where is it? I never deleted it. Where did it go? Because I'll get myself confused. I won't remember which service I used to load the data. And also, the student account is limited to 10 services, no more than 10 services at a time. So we're going to add DB2 warehouse on a cloud service only once. Now, your data, you will download the data from assignment folder. Please do not change it. Please do not change the data, okay? Just take it as is. Because I did some homework, I cleaned it up to make sure that it loads perfectly. Now, this is a danger zone here too. You're not going to close an application by just going ahead and clicking on the X button. Like see here, I'm in RStudio, right? I'm not going to click on this X to close the tab, because an application might not exit the right way that I wanted to exit, right? Do not install any R packages that you're not going to use. And I'll tell you, this is one reason this assignment may have been the hardest in the program for some students. It's because they installed all of the packages they could think of, and they tried to run all the methods they could think of. They got so excited. So, another thing, if the package installation, because you'll need to install the TM package, if it takes a little while, do not stop the installation. Just let it finish. Then, just remember you don't have the browser back button. Just pretend you don't have it, right? This one, I keep on reminding it throughout, but some people always do it. Just don't do it. Do not use Microsoft Word or any rich text editor to type your SQL code. Trust me, this is a very sad story, but it introduces some characters that could damage your code. For example, single quote, curly quote is not recognized by SQL, and it's a long story. It happened to a student the night before the assignment was due. And we were just sitting and cleaning up SQL code. It's sad. So the only way to fix it is to write it all over. Just keep that in mind. And also avoid using a rich text editor to type R code. The good editor is probably Notepad or anything like TextPad, Notepad++, and of course there are some Mac editors, but make sure you're not using the rich text editor, okay? Okay, now, this is a real danger zone. If you delete the service from your dashboard, guess what? The work that you just did, goodbye. There is no way to recover it. There is no recycle bin, okay? So if you do this, see that this is your service, and it has this menu, ellipsis. And if you delete your service, you would have to say goodbye to the work that you did forever. Alright, so just remember that. Now, okay, this is a secret for assignment for success. You have to follow all instructions carefully. You are going to complete the tutorial before you start working on assignment 4. You're going to use the file straight from assignment folder without changing any data, okay? Well, I still put the link to the data description. Well, so you click on that link to read the description, but you take the copy of the file from assignment folder, because trust me, I saved you a lot of hours just by doing some cleaning of the data. Now, here, this is important. Some of you ran into this. before you add the service, you cannot have more than 9 services in the dashboard, right? Because the maximum is 10. So this service is 1, right? If you have 10 already, you will have to find something to delete, right? The code that you write, you have to save a copy on your PC because you cannot guarantee that it won't be lost. Well, it should not be, at least the R code, but always have a copy saved on your PC. Or suppose that you need to submit your assignment, right? Tonight is your assignment, you will have to submit the code, of course, right? And for some reason you are unable to connect to an application. Application has a maintenance. Guess what? Huh? Well, perhaps maybe somebody was smart enough to have all the copies saved on your computer. You're not affected by the outage, right? And there are other numerous reasons, right? So you want to make sure you always have a local copy. Here, you want to choose the file from assignment folder, right? You're not going to be using your own data set. Well, it has to do, there are multiple reasons, okay? Now, you want to pay attention to question and answers discussion because if you run into an issue, there is a high chance that someone else ran into the similar issue, right? So maybe there is already a solution in a discussion, right? And of course, you want to contribute to our discussion. You want to post your questions because it will help the rest of the class. So you get a response from me, or from instructor, or from Linesh, or your classmate can respond too. So you could get a variety of solutions for the same problem, right? So now we're gonna discuss loading data and log. In a walkthrough, walkthrough is a perfect scenario when everything goes right, right? But we also need to discuss what can go wrong, and how do I know that something went wrong, right? So here it is. This is why. So let me assume that most of you started working on your tutorial. Should I assume that you have been able to add the stories? Well, I understand that I should not be assuming anything, but suppose if you have not added the service, you're gonna go here, right? See this here, services, and you're gonna go to the data services. This is how you add your service, right? And then you're gonna check. So in my case, I don't need to do anything because I have it already. I already edited it, right? But for you, you would have to click on that service here. And remember that, look, I'm in Watson Studio, right? And you want the one that looks like this. Do you see this? There are two services with the same icon. You want the one where it says DB2 Warehouse. You're going to click on Add, and when you click on Add, you're going to get to this page. You have to scroll down.
Sorry, Elena?
Yes.
Yeah, just please stress that again, that there are two things. One is DB2, the other is DB2 Warehouse.
This one.
Please, use the DB2 Warehouse.
Yes, that's the one.
Yes.
And when I click on the Add, I can scroll down and it shows me different plan options. So please ignore this $50. It's not going to charge you $50 as long as you're staying within the storage limit, as long as you're up to one gigabyte. But trust me, this is more than enough for what you're doing. And you're going to select the entry, right, and then you're going to click Create. And when you do that, you're going to be redirected to the Watson. I'm in the IBM Cloud right now, right? So what you're going to do is, this is the service page, right? You add the service only once. On your next login, right? When you log in the next time, what you could do, the way you would access the service is this. Well, you're gonna find the service on the dashboard. So let me go back. I have two pages in my case, but it's in here. Well, the faculty accounts have the 40 services limit. Yours has 10, so that's why you're seeing a lot of stuff. Now you're going to click on the service, right? So all of you remember the danger zone, right? You're not going to delete anything because as soon as I do it, It's gonna be a big mess. I'm gonna lose all my tables, everything like that. So now what I'll do, I'm gonna click on open, right? I click on open, and it's gonna take a little bit of time. On the first login, you're gonna see a little tour. It's gonna tell you what these screens are. So I would recommend that you go through it, right? And you go through the tour. Here, this is a service homepage, or you call it a landing page, right? And this is also called the application console. So what is it doing in here? This is how much space I'm using, in this case 0%. So whatever I loaded is not large enough to cause trouble. Here is a load activity. It's loading, it's going to load the status, right? Because what I did was I uploaded the airline data tutorial, the data set, right? The data for the tutorial. And then I also uploaded the 3 data sets, which are your options. Your options for the assignment 4. I have to test it, right? And yes, guys, I want to suggest that you stay through the end because I'm going to show you more stuff. I'm going to show you more than in a walkthrough. Trust me, I'll show you more stuff. Okay? Part of it is going to be the troubleshooting and some stuff for assignment 4. So now I'm going to click on the load. That's going to take me to the load page, right? What you have to do is you can drag and drop the file. You can drag and drop the file, or you can just click on the browse and then you find the copy of the file in your folder, right? So I'm going to load something different. I'm going to load something that you're not going to be using just to show you how to do it. Okay, so somebody is asking me a question. Let's see. Okay, let's assume that you deleted one time. What are you going to do now? Yes, if you deleted it, if you deleted the service, you'll have to, well, you will have to add the service again.
Sorry, I think some of us didn't see the question. Can you repeat the question?
Oh, okay. Okay, the question is, let's assume that you deleted one time. What you're going to do now is repeat your walkthrough. Well, the question is, what happens if you deleted the service, right? If Yelena deleted her service, what Yelena would need to do is she would have to go back and add the service again. But the problem is all of the data that I loaded in the tables, that will be lost. So if I have to do something, I would have to recreate. And there is a big problem. I would have to add the code. Even if I save the code, I would have to edit it because when I add the service again, the credentials are going to be different. I should have showed you the credentials, okay? Your credentials will be different, which means different host, different username, or different schema and different password, right? So you
can we
cannot...
ask, sorry, Elena, can we ask people if they have any troubles with the credentials?
Sure.
Does anyone have any troubles with the credentials? Were you all able to get the
because credentials are here.
Running. Yeah.
Well, for the credentials, it's just this. See this? This is the page. No trouble with credentials. Excellent. Thank you, Ed. Okay. But let me show you. This is what you do. This is a Thesaurus main page, right? Initially, there were no credentials. You just click on new credentials, right? And that's what it added. Then I click on an arrow to expand this information. And this is my username, which is also my schema name. And if I scroll down, this is a database URL, right? And here, if I scroll down, this is a password. Well, the reason you see a lot of URLs here because it is possible to connect to your DashDB account from other applications such as Watson Analytics that you use in an introductory database course, the Tableau. Well, you can connect to multiple applications. Like here, For this assignment, you're going to connect from the RStudio integrated environment. But in theory, you also could connect from the Spark notebook. You can also connect from the notebook and some other applications such as Watson Analytics that you use in DBST 6.1 course. I mean, Data 610 course, sorry. Data 610. Okay, for some reason I'm thinking slightly different. Okay, Data 610. It's an introductory course in data analytics program. Okay? Now, so this is your credentials, right? Okay, so now let's go back to where we were. We are here. Now, I selected my file. In this case, I'm loading the different data. Right? This is a source because source is the data that I'm going to load. I'm gonna hit next and see this. This is my username and also my schema name. It's in uppercase. I'm going to click here. Now I have options. And the options are I can upload the data into the existing table and I can create a brand new table. When uploading to existing table, I can append the data or I can wipe and overwrite existing data, right? In my case, I'm just going to click create new table and you would want to call it right. Okay, so now I'm gonna click on create and now I'm going to click on next, right? Well, not statistics available because we have not created the table, right? I'm gonna hit on next and now I'm gonna just click next, right? Well, that's basically a mapping. It maps a column in your spreadsheet to the column in the table that it's going to create. Right? So I'm going to hit next. Okay, so here are my settings. What this means is that sometimes it's highly possible that I could run into some warnings. I can run into some issues during the load. And whenever I run into 1001 issues, the load is going to stop, right? I can run up to 1000 issues. So now let's click on begin load. And take a look at this. This is a current status it's in. Okay, and now it's going to load the data. It's loaded. Okay, so what you want to do is, this is a good case scenario, and I'll show you why. This is the number of rows that were read from the spreadsheet, and this is the number of rows loaded. You want this to match, right? You want these two numbers to match. Here, it means 0 row rejected, which is good. All data was loaded as expected. This, you want to make sure that this today it's shown in your screenshot that you submit with a tutorial and also in assignment 4. Here basically it shows the time. You can see how long the load took, right? The start time and the end time. And it shows Eastern because that's the time zone that I'm in right now. So here, this is a source and this is a target. And this is a schema name, dot, and this is a table name, right? Here, I don't see any warnings, I don't see any errors, but normally, if you have warnings, you can open the log and it would show. But in this case, everything is good, we're good, right? But what if we're not? That's what I did. I have this slide just to illustrate. If things are not, if they're not as well as they're expected, then, do you see this little exclamation point? It indicates the load, something went wrong. And here you see the number of warnings, right? And then I can click on warnings to see more information what went wrong. In this particular scenario, no rows were rejected, right? No, nothing rejected. But well, we're still having a problem. So let me zoom. I want you to see the slide. Okay. So here, no, nothing rejected, right? But there are still problems. It has to do with initially, this is the data that I was loading. It was the data before cleaning. And what happened was some text fields, they had carriage return characters. Some textual fields had 2 lines in them, and for some reason, it was reading a single field as 2 fields. So that was the problem. But what I had to do is I had to read through the log to find out what the problem is and to do some cleaning to make sure that you don't need to deal with it for this class. So you want to check the log, but you see this, that's an indicator that something went wrong. Now, there is another indicator that something went wrong. Take a look at this. You want to check the number of columns. Do you see these things here? It added 2 columns. It's because the review field, it had some extra new line characters in it. So it was reading one field as if there were 2. So there was problem in the data that I downloaded initially from the web page. And I did some homework for you to make sure that you don't need to deal with that, so you can focus on analysis straight, okay? Because you will work on some data cleaning in a next class, in a capstone course, okay? So now, here, this is a data load options. I'm just showing you that when you load data to existing table, you can append or you can overwrite, okay? These are the options. You can append or overwrite. Now, let's see what's next. Here we are. So, after, this is the thing. Suppose that you close the page, right? You exited this page. You can still go back to this page. The older version of this program, you could not go back to it. Now you can. See this bottom section of the page shows the statuses of the previous loads. So suppose that here I loaded this data a while ago, maybe like a couple months ago. I was doing my testing. I can click here, and here I can see the time when I loaded this data for the last time. I was doing the test run on March 26th, right? And this is the number of rows read and the number of rows that were actually loaded. I can go back to this as long as I didn't delete my load, right? As long as I didn't delete the log. And here are the settings. This is the settings, right? And I kept the date format as a default, okay? And this means that the first row contains the column headings. You want to keep everything as default. I try to make it easy for you. And here you can click on View Table, right? But this is how you do it non-programmatically, right? I would recommend not to rely on the interfaces. Try to do as much as you can programmatically, right? And I showed you how to do it in a homework assignment. I showed you how to get the query, the table structure programmatically. All right. So now here is your Explorer tab, and you can always view this information. This is a table structure, but again, you want to know how to do it by running a query. So this is a query editor, right? Interface. Here are 2 buttons to keep in mind. If I click on Run All, I will run all code that I have here. Or I can highlight my query and click on Run Selected, right? So, okay, so here I usually don't do this. I usually save a copy of my code on my local PC, right? And I'm going to review the queries for you guys, since I'm really good at SQL because my degree, my actual master's degree is in the databases. So I did a lot of SQL and I've been doing it a lot for a living. So I prepared some good summary for you. So these are the parts of the select statement. The select clause, select part of the statement, you list the columns that you're going to select. The from part, you list the table name. Where clause is where you restrict the rows that gets returned. Group by is used for aggregating the data. Like for example, I can display the number of posts per airline, right? If I want to show the airline name and the number of posts per airline, I'm grouping my data by airline. Having is used to restrict the groups. For instance, I can show the number of posts per airline, but I only want to see the airlines that have more than 50 posts perhaps, right? Well, something like that. Order by enables sorting. Now remember this. These pieces here must follow this order above, this order. And there is also actually a with clause, but we are not doing it here. Right, so there is also this part that goes on top, it goes above the select, but we are not covering it here. Here, for this purpose, select from, where, group by, having, order by, they must be in this order. While its SQL statement must have at least select and from. If you don't include from, then what are you selecting? Well, in some variants of database language, allow just say something like select to, and it will implicitly select from a dummy table, but it's not the case here. You have to have select and a from, right? Now the spelling of the table name matters. So sometimes if you receive an error, something like the table does not exist, you always want to check the spelling. Make sure that the spelling of the column name also match the spelling of the column names in the database, right? Here we go. This is an example. This is a simple example of the query. So see this, I have a select clause. In the select clause, I list the fields that I want to see. Then I have my from clause, right? Where clause is restricting. For instance, I want to see the time zone, right? Only that is in this three, right? In. The in operator, it means that I want to see something that belongs in the list. And then the conditions in the where clause can be compound. So I want to see people in this time zone and people who got more than one retweet. And I sort the data by the airline, right? So what I did was I put all of these queries in my I put all of these queries. See this? What I've been doing, I try not to save my SQL statement in a Word document, right? This is all code that I have, and I put everything in a text editor. So this is the query that I just showed you. But this is approach you're going to take to work on it. This is an approach you're going to take to work on it. You wanted to do step by step. So let me paste these two guys in this editor. This is what you're going to do. Just scratch this. Forget about this piece here. Forget about it, right? This is what you're going to start with. I want to select the airline sentiment and just the airline. And I want to look at people in this time zone. That's it, right? That's it. That's all I want to see. So this is what I'm going to do. I'm just going to highlight it and do run selected. This is the process. You have to work on it slowly, right? Here, you show only there is a restrictions. There is a limit on number of rows that the query returns. It will return only the first 1,000, I think. And it's 100 records per page, well, 50 per page, rather. You can navigate between pages here. Okay, so this is the result, and here I can click on the detail. It just tells me how long the query took to run. And if there is an error, it will show here. You will see failed and the reason why it failed, right? Like
Hey, Elena.
Yes.
Sorry, I have a question. Is everything in DB2 case sensitive?
Yes. Well,
Okay.
it depends. It depends. Let's just do this. Let's just do this. Let's see what happens. Let's see what happens. No, it's not. It's not.
Okay.
Well, it depends on what we're looking at. It depends, yes and no. I'm gonna say yes and no. This is yes. This is
Yeah.
yes.
Okay, that's what the
This is yes. And also the query against the table metadata, that piece is yes. Because
the column names are column and table names are not case sensitive, but the data are all case sensitive, correct?
yes, but only in regular queries. There is a query that's in a homework assignment where it pulls the table information from the data dictionary. The data in the data dictionary is stored in the uppercase. So there you have to type it in the uppercase, and we'll look at it. But see this? This is how I start. I start slow. I got this to work, right? Now let's go ahead and add this. I'm gonna add user time zone, and I'm gonna add this retweet count greater than 1, right? And of course I want to display this one. Then how do I know that my query works as expected? So let me run. First of all, there are no errors, but I also want to make sure that it returns the desired data. So if I just skim through this, I don't want to see a time zone other than this. So if I see a time zone which is not one of these, something is wrong, right? If I see retweet count 1, then something is wrong. I need to go back and check my logic. And here I'm ordering by airline, and of course it's possible to order by more than one field, right? Oh, it says order by airline. Well, okay, yes, it's ordered by airline. But I'm wondering the sorting, it could be case sensitive. I know that at least in Oracle database, sorting is case sensitive. So if you have American in the uppercase, right, and American in the lowercase, it has an impact on the order. Okay, so there we go. Right, and you can sort by more than one field. Like, for example, this is Delta Airline, and I can throw in another one which is retweet count, right? So now, when in the order by clause, I can specify the column name, or I can specify the column position in the select clause. I can specify the column position. Like for example, here, I can do like this, right? I can select it all, and I can go run selected, right? So right now it's sorted by the airline, but also retweet count within airline. What I could also do, I could do this too, right? This is in the order by 2. This is in the second position, right? And then I can do this one is gonna be 3. So this is the position of the column in the select clause. I can do this. So just keep this in mind. Run selected. Okay, that's gonna be the same. Okay, now and by default it's gonna do ascending. I can always do descending. And also I can specify what I want to do with my null values, right? The values that are unspecified. I can add the condition nulls last or nulls first, right? Okay, so here it is. There is a query against, there is a data dictionary query. That one is case sensitive. I'm not sure if I put it here. I may have or may not have. This is an example that I was going to do. This is complex, but it might not be in here. It's in a homework assignment, and also it's in one of my files here. So basically, there is a table that stores the data about data. This is called the metadata, and here it is. It might be this. Yes, here it is. So this one, when you run this, you're going to change this to your username, right? So basically there is a table that stores the information about the tables in your schema, right? So this is going to be your username, and I believe that's different. See, okay, suppose that I forgot what my username is. I can do this. This is when I click on Explore, it's in here. So it's dash 7761, right? You're gonna have a different one. 7761. So I'm gonna do this. See this dash 7761. Okay.
Yeah.
So
this
is
this is one of the things that is case sensitive.
Yes.
If they are trying to copy from their credential files to here, you got to change the case. Okay. Yeah.
Yep. So this table is going to show me the tables that I have in my schema. So this is basically the programmatically how I get this information, and you can also get this information when you're in RStudio. So see this? There's a table name, creator, which is me, the time when the table was created, and column count. Now there are other fields stored in the table, but I'm only interested in this four right now. I don't want you guys to bother about the storage. This is database administration course. We are not going to get into this, okay? That's GBST program. Anyhow, this is how you get the table names programmatically. And another one, you can also get the table column names programmatically. But here, there are a few things that you have to change. You have to change the your schema, right? You have to change. And see this? One of you asked what happened if you delete the service. Well, you would have to change the code. You would have to also change the code, right? Okay, so here it is. Here, this is the table creator, and this is a table name, sentiment. So this is how you get this. Is the system table that stores information about the table. All right, you guys are dealing with database person. Sorry, cannot help it, but I like to show this. Okay, here is a name. This is a column name, table name. And this nulls means if the column can have, if the column is allowed to have missing values. In database there is a constraint. In general, you can define constraint called not null. Then the column must have a value, right? In this case, we don't have the tables. We didn't define the primary case. We didn't define any constraints. Okay, so now let's go back, and I really like to do complex queries, and I like to share how to do them. So here it is. This is the aggregation. You are required to write a query that shows the number of posts by sentiment. This is advanced, but for your purposes, you can do just a simple query with a group by, right? You can do just simple, but this is a complex. Let me go here. This is my code, right? You can just make it simple, and I believe I may have had one in I may or may not have had one in an assignment, right? But this is how you would do it. Is this? Let's copy this piece here, and I'm going back here, and I'm just gonna do this. I'm gonna do select, and here I'm gonna put the field name is airline sentiment. I just remember it. Well, usually in some databases you cannot have the field name in a table with the same name as a table name. Well, it let me have this here. Okay, group by. So let me tell you this. In your group by clause, must have all columns, all non-grouping columns from the select clause. I'll tell you this. In the group by clause of the query statement, you must put all non-aggregate columns from the select clause. Okay, just remember that. So what I'm doing in here is that I'm selecting the airline sentiment, and I'm going to display the number of tweets per sentiment. This is what I'm doing here, right? So group by airline sentiment. That's it. This is simple, right? But what if, let me run this thing here. Okay, right, so this is simple. But what if Yelena is a database person and Yelena is a reporting person, and she wants to see something like this? I want to see this. This is more fancy example. In this case I'm just doing a location. Okay, I want to create this table where the first column is location. The second column I want to see the number of positive tweets per location. Then I want to see the number of neutral tweets, negative, and then in the next column I want to see the total tweets. Okay, this is what I want to do here. This is a little bit tricky, and I'll show you. There is a function called decode, and what it does is the first input is the column name. The second input, it does this. If the value is positive, then it's a 1. Count function counts. So in this case, if the value is positive, it's a 1. If the value is not positive, it's null, right? So here it's going to do the count. Where count either ones, right? If it's a 1, the count function skips the nulls, right? So it's going to count how many ones I have. See this? Behind the scene, I'm converting this to a 1 if the sentiment is positive. So this is going to give me the count of positive tweets. Ed, do you have a question? Ed? I just saw somebody raise your hand. Oh, just wondering. Okay. Yes, go ahead, Ed. Please type your questions. Don't be shy. But this is what I'm doing, and this is going to do the total. And here I'm just going to show the location. Yes. Oh, okay. So let me see the question. The question is, can we also do this in RStudio? Yes, you can do this in RStudio instead of SQL. Yes, exactly. Then you're going to use add a data frame, and I was going to show you that too. But first, let's understand what this SQL is doing. Right? Let's first understand the concepts, because we're looking at the concepts in isolation first, and then we put it together. Okay, so here it is. Now, let's look at this. And see this here, having clause, what it does is that it eliminates the locations that have that have 25 or less tweets. I only want to see the locations with more than 25 tweets, right? Now keep in mind the difference between where clause and having. Having eliminates the group, where eliminates the single rows, right? So just remember that. Okay. So now let's go ahead. Let's take that thing. It in a. Well, the reason I have several files is because some of them are the your some files are your homework assignment, right? The queries that you have, and some queries are more advanced that I wrote for this demonstration purposes. So, but in any case, I don't want you to type your SQL code in Microsoft Word, right? So promise me that you guys are not going to do it, okay? So that's one reason I did not put the copy of the code in this time. I did not put a copy of the code in a Word file, right? So anyhow, so that's our code. Okay, so let's take a look. Okay, I guess, yeah, I know that I have it, so let's take a look at other queries first. And then after this lecture, I promise you that I'm going to give you a copy of the query, and you can play around with this, okay? How does it sound? Okay, so now let's move on. So here you understand what I'm doing, right? The decode part converts it to a 1, and then I'm counting it. And this one is going to do the total, right? But when I was developing this, I worked on it slowly. I first added just the total, right, for tweet location, and then I started playing around, adding positive, negative, and so on, right? And the sum should add up. This is one way to test yourself. 2 plus 25 is 27, right? So the numbers in all columns, these 3 columns should add up to the last column. Okay, now here, this is a subquery because you're asked to do a subquery. A subquery is basically the query inside another query, right? It's a query inside another query, okay? So it may return one value, it may return a list of values, and it may return like a virtual table. The subquery can be placed in the select part of the main query. Select from where having. Those are the 4 places in the main query, okay? And that is funny. I used to have a test question. In which part of the query can you put a subquery? People answered in parentheses. Well, that's right. But the question is really select from where and having, okay? Now, yes, you put it in parentheses. For example, you can use a subquery in a where clause and having clause to check who has something above average, right? So I put together one. I tried to put together a simple example here. There is a negative reason confidence field, and here I want to select the tweets that have a negative reason confidence above average, right? Okay. Yeah. Oh, you're asking for the SQL statement? Well, you want to do it in a SQL editor. But then the ones you do in RStudio that are analysis, I want to see you do both, okay? Okay, so now take a look at this. See this? Right? So this is a subquery. Here it is. What I could do in theory, I could calculate. I could run this little query first, and this returns the average. And then I can take this number and plug it in here, right? But what if my average changes? Am I going to run this query all the time and keep on plugging in? Of course not. So what I do here, I just plug it in the subquery, right? So this one is, I have it. I swear that I have it. So this is a SQL code, and okay, I swear that I had it anyhow. Okay, so basically what the inner query does, it calculates the average. It's in here, right here. So let's do this. Let me take that and paste this. I have to show you. And this is one reason I did not put it in a walkthrough file, because this is really complex and I wanted to show it to you live. So take a look at this. Take a look at this. What does this piece here return? Right? This is return the average, right? This query here is going to give me the average, right? I'm going to run this one. Oops, I have to close the chat for right now. And I'm going to do this. I'm going to run this. Okay. Ooh, I got an error. It's because, well, I got an error. It's because I mistyped something. You see this? If I get an error, you're going to click here, and it's going to show you, this is an error message. It's because I have an invalid identifier. I mistyped something, okay? I mistyped something. So basically, this is what happens. But, oh, I see this. It's because I had to put the semicolon. The SQL statement has to end with a semicolon. I put the wrong character. There we go. So this is the average, right? So what I could do, I could do this. I could copy and paste, and I could save this here, right? I could save this, and I could do this, comment this out. By the way, this is a comment. This is a SQL comment, right? So now what I'll do is I'll just run this. I just select it and run it. Okay? Now, tomorrow, my data is going to change, right? The data is subject to change, isn't it? what am I going to do? Am I going to run this query again and plug in the new number in here? Of course not. So what is the solution? The solution is this. I will put this little guy in here, little subquery. Right? And then I can just run it. This subquery, this little subquery, will be executed once for all records. Some subqueries executed once for each row in the outer query. Just remember that. In this case, this one is going to be executed once, and it's a single value subquery. It returns only one value, and in this case, I put it in a having clause, right? Because I'm interested in average for the airline. I'm not interested in overall negative reason. And the way you validate yourself is that you know what an average is, and you just spot check to make sure whatever is here is above average, right? And you can also add additional conditions, right? You can add the sorting and so on. But I'm just showing you what you can do. And also you can have several layers of nesting. Like I put together some examples. There is an example with more than one layer of nesting. Well, here, this example is what I showed you, right? Table metadata. Okay, so let's go back here. I did a subquery here, all right? So here is a table metadata example. And this is a subquery in a subquery, okay? So here, this is what I'm doing. I'm counting the number of tweets per location. See this little thing? Then I'm taking an average number of tweets per location. And then here, I'm listing the tweet location with the more than average number of tweets per location. Okay? Here, I cannot do what I just did there. What I did in here, I only have one nested subquery. It's because I'm looking at the overall average, right? This is the whole table average. In there, I want to look at it by location. See this? So what I'm doing is that I'm taking the number of tweets at each location and I'm taking the average. And then I'm using this inside of the main query. So just for you, I want to remember that you can have several levels, and see this. This is a subquery in a from clause. So it's like a little virtual table, I would say, right? But if there is subquery that you're using a lot, sometimes you may want to create a view. It's another database object. Sometimes you may want to create a view. If there is a little subquery that you're using at all times, you can create like a virtual table, temporary table, or view, whatever you call it, view, right? Anyhow, now here, this is a troubleshooting, not a valid SQL error. And what you need to do is, you will receive the error if your column is misspelled, right? Like this is an example, city. I spelled it as city. So you have to correct the table names and column names. See, this is an example of an error that you will see, and then you can click on details to do more readings if you'd like about the error. Now here, this is basically some questions from the last semester. The query output is limited to 1,000 rows. How do I know how many rows my query returned? See this? This is an answer. You could do a subquery. Select count star. Count star returns the number of returned rows, and then here you put your main query inside. Okay? This will tell you how many rows the query actually returns. Okay? Now in here, is it possible to increase the limit? Yes. And I'll show you this. Well, this was a common question that students asked. That's why I'm doing it. See this? I go here, and I can see here I can change the maximum number of rows. But keep in mind, you cannot go above 10,000. There is a top limit, there is a cap. Okay, you cannot go above that number. But yes, you can tweak a little bit. And this is a statement and stop statement indicator. And here, when you run all queries, it tells you what you should do, what it can do if there is an error message, if there is a problem. Okay, now, so this is the SQL part. Next thing is the R part. This is the fun part that we're gonna go through. For the RStudio, there is several ways you can access it. You can go to the Analyze tab here and click Launch DSX. Well, DSX is a former data science experience, which is also called now IBM Watson Studio. Then you can log in and you can access RStudio from the tool menu. Now, here is another danger zone. I don't want to have it open in more than one tab, right? I already have it open in another tab. So let's close this and let's go back. I have it open already. And this is my script here. And I'm going to do multiple things today. I'm going to share something that's not in the walkthrough. So here are familiar windows, right? Environment, the history. Okay, so this is a little bit similar to your regular RStudio. When you first time log in for the first time, you won't see the user library section, you will see the system library. Very important, do not install anything that you're not using. So when you install the packages that you have to use, it's gonna look like this. See this? I have only 6 packages in here. This is what you should have. And in fact, NPL and SLAM get installed when you install the TM. This get installed with it. But remember this, if you do the r.version, it will tell you the latest version, right? Here it is. Let's see. This is 3.43, which is almost the latest. The latest is 3.44. So this is almost the latest R version, which is excellent. Now, what you'll need to do is you'll have to install this package, IBM DBR. You install this only once, but on your next login, you may have to run this library command because you want to put this package in memory. Ignore this line for right now. Okay, here it is. So you want to load this library. See this? Because that's a library that you have to use to read the data from your database tables, right? So here, this is how you approach it. Do you remember the database credentials? They are in this tab. Here it is. So the way I did it, I click on this and it would copy everything to the clipboard. And then I would go to the textpad editor and I would paste the whole thing. But for your code, only thing you need is this one, username, and you need the host, and you need the password, which is at the bottom. This is the information that you need in order to connect to the database. And this piece here I already added because it's going to be the same for everyone. Hopefully it stays the same. Anyhow, if it changes, then you'll need to go and edit the code. So let's go ahead and run this. Well, my package is already in memory because I ran something before this session. Okay, so now, see that this is the driver, all of this is a variable definitions. I have to run this thing. And basically what I'm doing here, I'm defining my connection object. This is a connection, right? And now I'm going to connect to the database, right? And I'm actually going to show you more. It's in another script. This is your walkthrough script, but I have some additional stuff added to it. So now, this is either query. That command you use, it allows you running the select statements, right? And this is going to store data in a sentiment data frame. That's what you did for your assignment, right? Run. Okay, it read the data. Sometimes it's highly possible that I may not remember the table name correctly. Well, not a problem. This command IDA show tables, it's going to list all tables that I have in my schema. In my case, I have 5 now, right? And this is the schema name, which is your username, owner, Well, in this case, don't worry, you own your tables. But in general, this is different because in some databases I can create a table and grant you access. Well, not here, not in this environment, but in general. Okay, I saw the question. Let's see. Would our code also run in RStudio on your laptop? Excellent question, Ed. In order for this to run in your laptop, you would have to install some drivers. No, no, no. But another problem is you're losing the whole essence of working on a cloud in-memory database. Okay, so no, 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 don't do that. It might run, but you have to install some drivers, and you're using the advantage of working on the cloud. Just remember that, okay? Uh, Semesters ago, the application had a reader where we used to actually read data from the reader, and it was reading into several tables, and then it was fun because I could ask students to do the table joins, right? You know that I'm fond of SQL. Anyway, now here, suppose that I have well, I hope I answered this question. But now look at this. Suppose that I have a very long list of tables, very long. And I'm not sure how my table is spelled, but I know that it contains the thing air in it. So I can just run this and it will show me the tables that contain the string air. And here, this is just to check if my table exists, right? Now here I may have to give you this query. Do you remember the queries that I ran in a SQL to check my tables programmatically? I can do it here too. Well, in here, when I ran the query up here, I set it to I ran the query and I set it to the data frame. Instead, I can do this. I can just do this. This will output the results to the console window. So this is what I can do that. And this is essentially almost the same information that we just ran in a DB2 warehouse in the cloud. And this is another one. Okay? I wanted to make sure that you guys see this. Well, it's wrapping up because it does not fit. So I would have to do this. I would have to move this and then click on that. I can click on the up arrow to rerun the last command. There we go. So now this is showing me the same information. But here in the where clause, I want to restrict it to the table name. And of course, table creator, that's going to be me, right? So table owner is not the same as a table creator. In this case it is, but for example, in another environment, Lineage, he could grant me access to his table, right? It's the permission allowed, not in here, but in general, perhaps if Lineage grants me an access to his table, then he is going to be the table creator, and I'm going to be the actual user who is querying the table, right? It's different. Okay, so just remember, this is in database environment. This is not the same. Okay. Anyways, so here your table name, and you have a table creator and the column, and here it tells you if the column may have the empty values, and here is length, the number of characters in a column. Now remember, this is a varchar, right? So it means that if the value is actually 5 characters long, it will only occupy the space for the 5 characters rather than 27. If it was a character, it would occupy the whole 27, no matter what. Okay? So, anyways, this is how you can run the queries. This is number of tweets for airline sentiment, and you could actually take you can take the queries that we ran today and run it here just to practice. So now there is something else that is not in your walkthrough. Airline the trends. Because if you look at your assignment 4, you have an option. You can choose between several methods. You have done the network of terms, right? It's in the walkthrough. You have done the word clouds. You have done the clustering in assignment 2, but this is something that you have not seen yet, the trend analysis, and I'll give you this code. So the question here is, I want to look at how many posts, how my posts vary by day. When are my customers are more likely to complain about the airline? And what are the most common complaints and when? So here, this is what I'm doing for right now. Here, I'm reading all data into sentiment data frame, right? It's just going to read all. Okay. So I created a data frame, I call it sentiment, and I've read all data. Now what I have to do is I have a column called date created. And currently that column is stored as the text, right? So let's go ahead and look. And here, see this, you can toggle between the grid view and the list view. Well, you can run the str command to display the variable types. Or you can also check it here. Well, I prefer doing it programmatically, but if you take a look at this, the created, it's a character, see this? I must convert it to the date, and this is a formatting, right? Month, day, year. Alright, so this is what I did right now. Now I can calculate the number of posts per day. So see, this is what I did. Look, I created the field called post. I created a variable called post. And the post variable stores the date in the date format. I didn't actually convert in the actual source. This is what I did. And now I'm going to build, this is a table. I'm going to show you the counts. This is the number of posts per date, right? My next question is to find the date with the maximum number of posts. So here's the table, right? Table post, this is what it returns. And then reach max command, this piece right here, it's going to return me the position of the date with the maximum number of posts. Remember, this is a list, right? Or this is a table, rather. See this? This is going to give me the position. Number 7, right? So 1, 2, 3, 4, 5, 6, 7. See this? This one right here. This guy. This is a date with a maximum number of posts. And this one, it will show me this. It will show me only the date is the maximum number of posts and the maximum number of posts. Aha, very, very simple, right? Okay, now let's do something more complicated. I can look at the, here is again, variable post, and I can do the plot. I might be interested in a number of posts per day, right? This is just the total number of posts per day. I converted this as date, and then I'm just gonna do plot. And the plot is gonna do the frequency count. Well, this is hard to read, right? I would rather do the line plot. And just line. That's it, right? Does it really help me much? Not really. I can enhance it further. I can do the separate line per sentiment, right? Can I do this? Yes, I can. So to do that, there is more than one way to do it. This is a hard way to do it, is to use Dippler package. This is a package. Now let's uncomment this. This package is already installed. What you have to do is you just have to load it in memory, right? You have to load it in memory. And of course, you always save when you make changes. What I'm going to do is, I'm going to run it now, and it's going to show me the number of posts per sentiment. Again, I'm reading my, data frame, and I'm going to call it DRS. I just call it this way. I'm going to run this line of code. So this is reading the data, right? Here, I'm just converting tweet created to the date, right? Nothing fancy. Here, what I'm going to do is this is using the summarize function in the declare package, and what it's calculating the number of posts per day. This is a count, right? It's gonna do the number of posts by airline sentiment by date. Okay, so this should return me the number of posts per sentiment per day. Right? I'm gonna do this, and then if I do this one right here, if I do this, right, just to see what's going on, this is a list like this, right? This is what this returns, right? I have the sentiment, and I have the date, and I have the count. So now here I'm using the ggplot package. This is advanced way, and I'm going to do the color. See this? Each line I'm grouping it by the airline sentiment, and the color is a sentiment, and I want to have the tweet created for the x-axis, and this is the data that I'm using. So this is a little bit advanced ggplot package, right? Okay, so I'm gonna just do this and do this, and now see this airline. Okay, and here is per day. So here I can run analysis. I can tell when I had more negative plots than positive, right? I can just look at the timing. When I had the most posts, when I had mostly posts were negative, mostly positive, and then I can even drill down further, and I can look at my by airline, right? So this piece in here, it will do by airline, and it will look only at the negative tweets, right? So what I'm doing here, I'm running another SQL statement. It will create daily sentiment by airline, and here I'm doing almost the same thing. I have to convert it to date, and then I'm gonna generate the table that looks similar to what I just showed you, but it's gonna do breakdown by airline, and this is a plot by airline. But I'm only looking at the negative post, right? I have several options here. I could take a subset of data that I already loaded, right? Assuming that I loaded the field that I needed, but which I did not, right? Or I just ran a brand new query. Look at this. I'm only selecting the field that I need just to conserve the memory. And also, you'll be running the queries, you'll be generating a bunch of data frames. Remember, you have your friend is rm command. You want to delete anything that you no longer use. Because, look at this. If I swap this to the grid view, I can see how much space my data frames take. And I can even order this by the space. And then, see this? This is a problem. It can become a problem, right? And your matrix M is going to take the most space. I deleted it. And I deleted it because it was really huge. I don't need it right now. So I can just run rm command to delete what I don't need to save the space, because I've had students who got up to 100 in here. Okay? So I'm going to give you this code. There are more examples, but since the time is getting late, we have to start wrapping up. So I summarized it for you, and these are the packages that you would use. They are pre-installed. You don't need to install them again. These are the steps, right? The credentials part, right? I just decided to repeat it again for you, and we just did this. These are your friends, right? You can check the table data programmatically from R, and this is what I just showed you. I just put this in a slide, so that way you have something for your reference, right? So this is how to troubleshoot. Suppose that you get an error message. You want to check, suppose that this did not return anything, right? You want to check the syntax of your query in here. If something is wrong, take this query, copy and paste to the SQL editor, and troubleshoot the query. First, you want to make sure that your query works, and then you take it to R, okay? So that's the thing. You can run it within R, but you also want to make sure that your query is working, that you for sure know the table names and everything like that, right? Here, I just put a summary of what you can do. The time analysis, right? This is what we just did. And this is troubleshooting. Some of you already received this error, so you want to make sure that if you already have 10 services, you have to delete one. And this is, you get this error if your session timeout. This is done for security reason, and I'm not quite sure what the setting is on the DB2 warehouse on the cloud, but a lot of government databases have a setting to 15 minutes. A lot of federal government have a setting for security reason 15 minutes. So if you took your lunch break, you have to log in again when you come back. Okay? Oh, another thing is that do not enter your credit card number, okay? Do not enter your credit card number. Remember that when you have about 2 weeks left, or maybe even 1 month left on your account, you get another promo code, and you have to apply the code before the current code expires to stay out of trouble. And the trouble is, as soon as your account is expired, it's harder to add the code to expired account. We just went through it with one of your schoolmates. I'm not gonna say names, but we just went through a lot of difficulties because the deadline to enter the code was missed. Okay, so let me see the question from, and okay, I'm going to read the questions. I would be interested in the drivers you mentioned that would be required to run locally. Okay, well, the drivers, I have not tested it myself, but it's somewhere in it's not in here, but it's in there is a page called downloads. There is a page called downloads. Okay, it's not in here, but there is a page. It's called download. Okay, trust me, it's somewhere in here. Oh, it was hidden with this. So somewhere there is a page, it's called the download. Okay, and that's where you get it. There might be a link on the main page. Oh, see this? I just reproduced the error. You would have to click on the sign in. It's because I did not do anything in this interface for some time. And if that happens, then you have to log back in. But yes, there should be a link somewhere here that you would need to download. After class, you want to run analysis after class. So let me tell you that your account is still active. You have the subscription for 6 months, and then you can get more. You can get more by entering another code, because your student email account is still active. As long as your student account is still active, you can get another code. But very important, get the code 2 weeks before it expires. And a lot of your schoolmates, they use these applications in their capstone course. So I strongly recommend that you guys get another code. Why not? You get another code. Oh, here it is. Look at this. I click here and you select downloads. That's where that would be. Somewhere in here, okay? Somewhere in here there are drivers that you would need to get. I have not tested it, okay? But it's in this page. But that's a thing. Please don't do it for this assignment. Please don't do it. Okay? If you do it, we are very good at catching it. It loses the whole essence of the assignment. But the thing is, if your account becomes inactive, then you won't be able to access the service. So that's the thing. Once your account becomes inactive, you won't be able to access anything. So you want to keep your account active by applying another promo code, right? Before the current code expires, you would go to the IBM Cloud and you just apply the code. See this? You go to Manage Billing, and on the billing page, you would need to apply next code. You follow the same instructions that you did when the course started to get the code. And then you just do this. You go in here, alright, and you click on apply code and enter the code. That's it. Just as you can see that. You can see that every year I had to go in and do apply because the faculty account is 1 year and the student account is half a year. So you go to your account and apply because once you enter the credit card no good. You can no longer go back to trial. So this is important. Do not enter your credit card. Okay, this is a danger zone. No, 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 no. Okay. Promise me you're going to remember and you're going to keep your account active. All you need is your student ID to obtain your student email to obtain the promo code. You are still a student. You're taking Data 670. That's student. It's capstone course. Right? For as long as your email is active, you should be able to get the code. Right? Well, faculty is a little different process, but for the student, you use your student email and you got another half a year. Why not? Okay. Uh, you have your demo, what's that? Both in R and SQL. Which one we need to use for the assignment? Okay, the question is, I showed SQL and I showed R. Which one you need for the assignment? You have to use both. You have to use both. Oh, what? You asked, Ed, you asked if you lose your student email after the capstone course? Oh, wait, I'm sorry. The question is if you use your student email after the capstone course. Linish, may I ask you, do you still have access to your student email? Linish?
Yeah,
Linish?
yeah, do have access to student email.
Okay, yes, so you do. Okay. Because I did not know, I did not have a question to, I'm sorry, I did not have an answer to for how long the student account stay active. But I think you do. You still have active, but I was not sure for how long, but I'm trying to remember because Lenish, you took Data 650 in 2016, right?
Uh, 2015.
15, yes, because you were in the second group of students, so you graduated 2016, and you still have access. It has been about what, 2 years? 2 years?
Yeah,
About
yeah.
2 years.
Yes. So I had to ask Linesh because, well, because at the time when I was student, we did not have a student email. At the time when I was student, it was about 10 years ago. We did not have a student email account like this, so I never had one. But so that's the reason I had to ask Linesh this question. So you're going to have, and while you have it, you can activate it every half a year. You get a new code and use it. Why not? That's it. You just imply the code. Yeah, but yes, your student email is still active. Okay. Yes, and yes, Mohammed, you have to use both. And if you read the assignment, tutorial explicitly tells you we use both, and the assignment you have to use both. I want to make sure that you know how to use both. Okay. And yes, sometimes if your SQL within R does not work, you want to make sure it's a working SQL. You have to go to the database. Okay, I'm glad I answered the question. Do we have more questions? It has been a long session, but it pays back in the end. So yeah, I'll give you a list of what not to do because yeah, sure, you're the most welcome, Neil. But I mean, people who said that this was the hardest assignment in the program, I think some of them made it hard for themselves by waiting until the last minute, by doing something on a list of what not to do. Okay? So I like to show what not to do. That's me. Okay? So let's see. What else? More questions? More questions? Going once? Going twice? Unless if there is anything that you want to add or Gapoti? Any
No, I
insights?
think you covered it all from just what not to do. I don't know if you covered that as well, but in between you did allude to it, but about not using any other credentials but your own. So just make sure you're not just kind of typing or reading from the Word document, but using your own credentials. I know there was one or two students who kind of used the credentials from the Word document, and somehow it did run, or there was some confusion about did it run or not run. But in any case, you don't want to use the credentials from the instructions.
Mm-hmm. Yes. Well, I try to delete it, but it's really hard because, well, it's a lot of things involved. It's
Yeah,
really
it's just a snapshot. It's just a
yes.
snapshot of you kind of going over it. But someone else, and also the schema name would also be different. So do not be surprised if the schema name is different than what you went through and showed to everyone today, or what's in the instructions.
Yeah. So, yeah. Well,
But otherwise, everything's covered. Thanks, Elena. This was a great session.
sure. And Gaupat, anything to add? Anything that people should not be doing or should be doing? Anything? Gaupachi? Anything else? Well, if you don't have any more
Sorry,
questions,
I think I was on mute in
sure.
two pages. Yeah, no, I said I don't have anything to add. I think you have covered everything. I just hope people get started early. That's all.
Oh yes.
Yeah.
Oh yes. And yeah, I'm going to keep an eye on maintenance if there is any, but we'll see. Hopefully not. There is one scheduled after the class ends, because yeah. But I'm not even well. I'll keep checking and I'll let you know if there are any outages planned within next 2 weeks. Okay.
All right.
All right.
Thanks, Elena.
Sure. So
Thanks,
I'm
Dinesh.
gonna stop
Everybody.
sharing
Thank you.
and I'm going to stop the recording.